All right, we're going to continue chapter 7 today, and we're going to do section 7.2, which is about simplifying expressions. So, when do radicals need to be simplified? If the radicand is an exact power of the index or contains a factor that is an exact power, it needs to be simplified. If the radicand is a fraction, it needs to be simplified. And if the radicand is in the denominator of a fraction, it has to be simplified. So let's take a look at the square root of 169. Now, if 169 is a square root, if we could take the square root of 169, we need to do it. So we can simply plug it into our calculator. What is the square root of 169? Oh, it is 13. So we need to write 13. What about the square root of 20? We put the square root of 20 in our calculator and we get some sort of really weird decimal. We don't like decimals. Well, what we can do is that, the square root of 20 can be broken down into factors. So we have to break 20 down into factors. So 20 is going to be broken down into 2, 2, and 5. If you like to do factor trees, that's what you probably will want to go back to doing. So again, 20 is going to break down to 2 times 5. And notice that we have two 2's. We have two 2's, which means that we can pull this 2 out, leaving us 2 square roots of 5. So that's how that works. What about this number? 25, a to the 6, b to the 2nd. Okay, well 25 can be rewritten as 5 to the 2nd power. Then we have a to the 6, 8, and then b to the 2. So remember, we are looking for groups of 2. 5 to the 2nd power is 5 times 5. So that's 2 5s, which means we're going to pull the 5 out. A to the 6 is 3 groups of a to the 2nd, right? A to the 2nd times a to the 2nd times a to the 2nd, right? So that means we're going to pull a to the 3rd power out, okay? And then we have b to the 2nd, which means that we can pull a b out. All right, so let's practice. Square root of 32. So the first thing you want to do is you want to break down 32. Okay, so you can use a factor tree, however you want to do it. But 32 is 2 times 2 times 2 times 2 times 2. So it's 5 2's, right? So every 2 2's, we pull out a 2. So for 2 2's, we have 1 2 on the outside. For our second pair of 2's, we have another 2 on the outside. And then we are left with 1 2 on the inside, leaving us 4 square roots of 2. Because remember, we pulled out 2 2's, and 2 times 2 is 4. Next one, we have 4 roots of x to the 12th, y to the 4th, and z to the 5th. So now we're looking for groups of 4, right? So x to the 12th, that is 3 groups of x to the 4. So that means we're going to have x cubed. And then we have y to the 4th. That's 1 group of 4, which means we're going to pull out 1y. Then we have z to the 5th. Z to the 5th is 1 group of z to the 4th. So we're going to pull out 1z, leaving us a z in the inside of the radical. So let's practice. We need 3 roots, a to the 11th, b to the 6th, and c to the 9th. So a to the 11th is going to give us 3 groups of a to the 3rd, because that's 9 a's, and then we are left with an a squared on the inside. So we're going to get 3 groups, so that gives us a to the 3rd, and a squared stays on the inside. Now b to the 6th is going to give us 2 groups of a to the 3rd, so we're going to pull out a b squared. C to the 9th is going to give us 3 groups of c to the 3rd, so we're going to pull out a c to the 3rd. Okay, and so that leaves us number 1. So why don't you try some problems? You're going to do 7.2, number 2 through 6 evens. I'm available for help if you get stuck. Just let me know, and you have a good day.